Now we're going to talk about third-degree price discrimination. This graph illustrates the effects of third-degree price discrimination. I have two submarkets, market segment 1, market segment 2. So I've taken the total demand for the product and somehow split it into two different segments. The quantity in each submarket is where marginal revenue intersects marginal cost. So Q1 is the quantity that maximizes profit in the submarket 1. And if I go up to the demand curve on that quantity, P1 is the profit maximizing price in submarket 1. Marginal cost intersects the marginal revenue in submarket 2 above Q2. So Q2 is the quantity that maximizes profit in segment 2, and P2 is the price that maximizes profit in segment 2. With some analysis, we can show that the margin of price over marginal cost is higher in the submarket with the less elastic demand, that's submarket 1, and the margin is lower in the demand, or the margin is lower in the submarket where the demand is more elastic. So at this quantity, the demand in submarket 1 is less elastic than submarket 2 is at quantity 2. Therefore, submarket 1 has a higher margin of price over marginal cost, and submarket 2 has a lower margin of price over marginal cost. This also means if the marginal cost curves are identical, price will be higher in the submarket with the less elastic demand and lower in the submarket with the more elastic demand. These two graphs have tried to draw, are trying to depict marginal costs that are identical. Therefore, P1 is higher than P2. Now you might ask, what happens to total output? Suppose I've got a monopolist that charges a uniform price and produces some quantity QT. Is QT higher or lower than Q1 plus Q2? The answer is, it depends. The good news is, we're not going to worry about on what it depends in this class. So total output may rise or fall in third-degree price discrimination relative to uniform prices. Let's work through an example. A bit contrived. Let's assume the firm in our earlier example is able to segment the buyers willing to pay 6 or more for a unit of output from the buyers not willing to pay 6. Pretty artificial. We've got the high-priced buyers in one group and the low-priced buyers in another group. This gives us two submarkets, which I'll call 6 plus and 6 minus. The 6 plus, they'll buy a total of 5 units. If the price is low enough, willingness to pay goes from 10 to 9 to 8 to 7 to 6, which means if the firm sells, for example, 3 in the 6 plus market, total would be 24. We can calculate marginal revenue. It goes 10, 8, 6, 4, and 2. The submarket 6 minus, if I want to sell 1 unit, the highest price I can charge is $5. The most anybody in that submarket 6 minus is willing to pay is only $5. So if I charge a price of 5, I'll sell 1. If I drop price to 4, I'll be able to sell 2, and on down the list like that, which means marginal revenue goes from 5 to 3 to 1 to -1 to -3. So what quantity maximizes profit in 6 plus? It's the last unit where marginal revenue is above 2.5. So in submarket 6 plus, I want to sell 6 units, charge a price of 7, and we can do the math. We can figure out that we're going to make a profit of profit of 18 in that submarket. There it is. We can make a profit of 18 in submarket 6 plus. What quantity maximizes profit in 6 minus? Well, marginal revenue of 5 is higher than 2.5. Marginal revenue of 3 is higher than 2.5. Marginal revenue of 1 is not higher than 2.5. So in submarket 6 minus, I want to sell 2 units, and I want to charge a price of 4. And if I do that, I'll make a profit of $3 in submarket 2. So the total profit for the firm is now going to be the sum of what I get in market 6 plus and market 6 minus. The total profit is going to be 18 plus 3 or $21. the increase in profit from 18 to 21. Again, 18 is the profit the firm could earn if it charged a uniform price. The increase in profit from the profit it earns at a uniform price and what it can make in third-degree price discrimination is the reason firms want to, and in fact do, engage in third-degree price discrimination.